Lesson 8.5 is on adding, subtracting rational expressions. So we just got done multiplying and dividing. Now we're moving on to adding and subtracting. In order to add and subtract, you just simply need a common denominator. If you have that, you can go ahead and just add the numerators, leave the denominator, reduce, take a 2 out of both. This one will be 4 over x. Also looking for restrictions. X can't be 0. Can't have the bottom equal 0, and 2 times 0 is 0. So that's a restriction and the only one. Example 2. Example 2 has common denominators, so we can just go ahead and put these together. And we'll have an x minus 3 on the bottom. In addition to that, I can say the restrictions are x cannot equal 3, because 3 minus 3 is 0. I got to be careful here because the minus in the middle, some kids will mess up there. It's lots of students over the years make a mistake with the fact that we need to go -7 minus -1. So my suggestion is just change that to plus, switch both signs, and you should have 4x minus 2x, which is 2x. Students usually get that, but that where the mess up is right here. It should be -7 plus 1, which is -6. Then you look to factor, take a 2 out of the top, and cancel, and get your answer of 2. So if I were to plug anything into this expression for x besides 3, I should get 2. So if I say, hey, plug in x is 10, you should know the answer is going to be 2. Hey, plug in x is 9, the answer is going to be 2. If I say plug in x is 3, well, then you say you can't do that. That's undefined. That's a restriction. Example 3. Example 3 does not have a common denominator, so I would have you factor. And the only thing to factor is the right-hand side. I can take out a 3x squared. That's 6x cubed plus 3x squared above here. And then that would leave me with 2x plus 1. Now to find a common denominator, I want the smallest common denominator. So to find the smallest common denominator, I want you to figure out what goes into both of these evenly. And hopefully you can see that 3x squared goes into both. In fact, I could take the left-hand side here and write it as 3x squared times x. So I can make it so that they both have a 3x squared in common. And whatever they have in common, I'm just going to go ahead and put over here. And then I'm going to write down what they have that's extra over on the right-hand side. So on the left-hand side, there's an extra x. So on the right, I'm going to write the extra x. And over on the left, there's an extra 2x plus 1. So I'm going to write a 2x plus 1. Now in the end, I would change that to 3x cubed times 2x plus 1. Wouldn't leave it 3x squared times x. I just pulled that apart, so it's a little bit easier to see what the extra was. There was an extra x on the left-hand side, so I needed an extra x over here. And then there was an extra 2x plus 1, so I put that over there. Okay, so now, what do? We got to multiply top and bottom so that the denominator is exactly the same as what I have right here. So I need 3x squared, x, and 2x plus 1. Well, this one has 3x squared and x, but it doesn't have the 2x plus 1. We'll take top and bottom by 2x plus 1. If I do that, I'm going to end up with an 8x plus 4. If I distribute that 4, I'll get 8x plus 4. On the right-hand side, I've got a 3x squared, I got a 2x plus 1, but I don't have an x. And we go x times x is x squared. X squared plus 8x, just going to put it in order. I would look to factor the top. Does anything going to multiply to equal 4? Anything multiply to equal 4 and add up to 8? And the answer that's no. So this is a good answer. I needed to put my restrictions. I haven't done that yet. X can't equal. Going back to my factored part, here and here, X certainly can't be 0, because 3 times 0 cubed is 0, and so is 3 times 0 squared. But also X can't be right here negative a half. Subtract 1 divided by 2 and you get negative a half. So those are the two things that I could not plug in for X. Okay, next problem. Gotta get some stuff out of the way here. Maybe, maybe not. There we go. Okay, next one. Same type of deal. Factor. So I'm going to take on, well, I'm going to change this into x plus 3, x plus 3. Factor on the right. That's x plus 3, x minus 3. That's what that is. There's a minus in the middle, so I'm going to make this plus negative. I'll get my restrictions right now. X can't be negative 3 because that would make, oh, well, either this, or this 0. And then x can't be 3 either, because that would make that equal 0. Common denominator, what do they have in common? They both have an x plus 3. Write down an x plus 3. Well, what else do they have what else do they bring to our party here that isn't already there? Well, this one has an extra x plus 3, so I can write that down. And this one right here has an x minus 3. The left-hand side here's got 2x plus 3's, but it doesn't have the x minus 3, so I'm going to multiply this one by x minus 3. Get rid of my restrictions up here, they're kind of in the way. And I'm going to have to FOIL that out. Now if I take x minus 3 times x plus 1, those two quantities, I'm going to get x squared. X minus 3x is negative 2x, and negative 3 minus 1 is negative 3. The right-hand side has got an x plus 3 and x minus 3, but it doesn't have that second x plus 3, so this one needs another x plus 3. And I move the negative with the 1, so I need to distribute that. So I'd have negative x minus 3. Add like terms on top, and you get x squared minus 3x minus 6. And you can leave it in factored form. I guess I'm going to write x plus 3 quantity squared. That's a little bit shorter. Try to factor the top, but nothing multiplies equal negative 6 and adds up to negative 3, so that's a good answer. And again, restrictions where x couldn't be negative 3 or 3. Example 5. Here we have totally different denominators. Now some people think, oh, I'll just subtract 5 over here, or I don't know, they do some crazy things, or multiply by negative 5. That doesn't work. These are totally different factors. You can't treat this x and 5 as separate terms. They're together. That's a binomial. So you need to say my common denominator has this factor and that factor. And again, I would encourage you to change that minus up here to plus, and then switch the signs of everything on the upper right. Restrictions, of course, would be x can't be 5 and it can't be negative 4. And it's just a matter of what do we need for each fraction. On the left-hand side, I need x plus 4. Distribute the 3 and you get 3x plus 12. On the right-hand side, I need the x minus 5. Make sure we're foiling it out. Distribute that, I'm going to get a negative x squared. Then I got positive 5x, positive 2x, and negative 10. Add like terms in my numerator. And negative x squared, 3x, 5x, and 2x are 10x. And 12 minus 10 is positive 2. This is a perfectly good answer right here. Otherwise, you could take a negative out, put it out front, and change all the terms in the numerator, and that also would be a good answer. Okay, we're going to move on. You have to be kidding me. Well, this is really, it looks pretty scary. This is what's called a complex fraction. And I'm going to have two examples for you here. I actually added an extra one here. So leave room at the bottom of the sheet to go through the next one. So I'll get two more problems. This complex fraction is basically one problem in a numerator and another problem in a denominator. I could treat this as a huge division bar and say there's a problem in the numerator and there's a problem in the denominator, and do those separately. So let's go to the numerator. The numerator would factor first into x plus 2, x plus 4. 2 times 4 is 8, 2 plus 4 is 6. Common denominator would be x plus 2, x plus 4. All I need on the left-hand side is an x plus 4. So I got x plus 4 times x. That would give me x squared plus 4x. That's what that would turn into. And then I got x squared, 4x and x. Add those together is 5x. And there's a minus 6. Now you should factor that top just in case something cancels. So I would say what times what is negative 6 and adds up to 5. That'd be positive 6 and negative 1. Now nothing canceled here, but maybe it will later on. I would also encourage you at this point to be thinking about your restrictions. So far I see that x can't equal negative 2 or negative 4. Those are the things that would cause the denominator to equal 0. Okay, now I'm going to do the denominator. Treat that as one problem. Bring that down here. So I've got 3x minus 11. I would factor out the 2 plus x plus 3 over x plus 2. Then I need a common denominator, and the common denominator looks like I would simply need to multiply the right by 2. And that would give me 2 times x plus 2 in the denominator. Right here, this would turn into 2x plus 6. Distribute that 2, you'd have 2x plus 6. So my numerator would be 3x plus 2x is 5x. Negative 11 plus 6 is negative 5. I then look to factor that. I can take a 5 out of the top and then just leave it as 2 times quantity x plus 2 in the denominator. Now, based on the bottom part here, x can't be negative 2, but I already said x can't be negative 2, so I don't need to write that in my restrictions again. So now I've got two parts. I've basically got two fractions. I've got this fraction right here. That was my numerator. This fraction down here is my denominator. And I was dividing a numerator by denominator. What do you do when you divide fractions? Well, you simply multiply by the reciprocal. So here's my numerator. Now I'm going to multiply by the reciprocal of the denominator. I now have an x minus 1 binomial factor in my denominator. That tells me that I have another restriction. X can't be 1. And then we're going to cancel the x minus 1s. Cancel the x plus 2s. And we're left with an answer of 2 times the quantity, x plus 6, over 5 times the quantity, x plus 4. Okay. Oh, like I said, I got one more because there's a little different type in your book here that we need to have you ready for. So just write this other one at the bottom of this page, that would be great. And here's what it looks like. And here's how you do it. You work your way from the bottom up. So I'm going to simplify this problem first. I'm just going to do x plus 1, x plus 1 over x plus 1. Just like we just been doing. So I need a common denominator. The common denominator would simply be x plus 1. In order to get x plus 1, I need to multiply this by x plus 1. If I do that, I'm going to get x squared plus x. And then there's going to be this plus 1. Okay, so the blue stuff that I circled over here on the left is the same as x squared plus x plus 1 over x plus 1. Okay, well, this is what I haven't dealt with yet. I had 1 plus 1 over. So I need to put x squared plus x plus 1 over x plus 1 down here. And you might be thinking, wow, that looks worse. Well, it might look worse, but we're still on the right track. It's not too bad here. The key is you have to understand that this right here is the same as 1 divided by x squared plus x plus 1 over x plus 1. Which all that means is go 1 times. X plus 1 over x squared plus x plus 1. So if you have 1 over, that's basically just the reciprocal. Like if I said, what's 1 divided by 3/4? You get the reciprocal 4/3. 1 divided by 8/7, you get the reciprocal 7/8. So this 1 over simply turns into, you're going to have the 1, you're going to have the 1 plus, and then it flips over. Okay, so I just flip that over and the 1's gone. Okay, so now we're getting closer. Now I'm going to do this part, working my way up. And I'm going to need another common denominator, so it's kind of the same thing here. Common denominator would be x squared plus x plus 1. So the x plus 1 on the right stays the same. On the left, you're going to take that times x squared plus x plus 1. Top and bottom times x squared plus x plus 1. I got messy there. Let me clean it up a little bit. X squared plus x plus 1. So that's what we're going to take top and bottom by in order to get the common denominator. So I take 1 times all of these, and I get x squared plus x plus 1. I got to add that to the right-hand side. I get x squared plus 2x plus 2 over x squared plus x plus 1. Okay, so that is all of this right here. So basically I need to do 1 divided by that. So my answer is simply the reciprocal. Okay, so the ones in the assignment are shorter than this. It's the same concept though, where if you end up dividing by a fraction, just think multiply by a reciprocal. Just make sure you're checking your odds as you go to ensure that you got the idea down pat. So, thanks for watching. Have a great day.